Welcome to day 10. Homework is packet page 69 to 70, so you can write today's date next to day 10 on the calendar. We're going to be looking at density today, and we'll give you a little bit of time to try the warm-up. Notice we are rounding here, so you should be putting the pi in your calculator. And we should be working with some volumes, so you should be able to use the reference sheet that is on the inside cover of your packet to help you out with this question. So we're going to pause the video for 3 minutes for you to do this warm-up. Make sure to include units on your answer. If you need to borrow a calculator, make sure to let the sub know, and they can get one for you to borrow from the top left drawer in my desk. So our strategy here to find our full volume, we're going to do our volume of a cube minus the volume of our cylinder. A cube is basically a prism where the height is the same as each of the sides and the base. So we can use that prism formula, which is area of the base times height. Our cylinder formula is also area of the base times the height. Well, when you have a cube, the base is has sides the same, so our area of the base is going to be 6 times 6 times the height, which is also 6. Now for our capital B, remember capital B represents area of the base for the cylinder. You should be replacing the capital B with whatever the formula is for that base's shape. So in our cylinder we have a circle, so capital B is getting replaced with pi times radius squared. We have a 4-inch diameter, so we'll have a 2-inch radius. And then the height in the cylinder is just the same as the height of the cube, which is 6. From there, we just put it in the calculator because it told us to round. And we should be putting the pi in as well. So we get 140.601 ... some other stuff. They tell us to round to the nearest tenth. So we look at the hundredth spot, we have a 0. So that keeps the tenths as a 6. So we have 140.6, and our units are inches cubed. So you can stick your warm-ups away. We will move over to the homework. If you have a sphere, no matter where you slice it two-dimensionally, you will have a circle. In number 2, if you have a right triangle and we're spinning it around its altitude, the three-dimensional shape would be a, I reverse that. To get the cone, you would have to spin the right triangle around its altitude in order to get that cone. From our cylinder, you could get a circle if you sliced it horizontally. You could get a rectangle if you sliced it vertically. And an ellipse is what in everyday language people would call an oval. If we slice it diagonally through the rounded parts, we would end up getting a shape kind of like that. So the triangle is the only one that could not happen. We've got a triangle here. If it's rotated around ED, the three-dimensional shape would look something like that. So we have a cone. If we have our rectangle, spin it around the line, we'd have a three-dimensional shape that would look like that, so a cylinder. In 6, we want to be thinking SOHCAHTOA. So from the 48 degrees, we have O and we have H. So they had labeled that as an H for the height of the pyramid, but just realized in terms of our SOHCAHTOA, that's O and H. So therefore, we have a sign. So our variable of H goes over the 12 because it's O opposite over hypotenuse. We'll put the sine 48 over 1, cross multiply. It's been a little bit since we've seen some of these. Make sure your calculator's in degree mode. And then rounding to the nearest hundredth, we have 8.92. To find a length of a side in the base of the pyramid, this side here is double the length of the base in this triangle. So I called in our picture, I called that base in the triangle X. So that means the side or the base side in the pyramid would be 2 times whatever X is. So I'm just going to do a cosine now because the X would be our adjacent and the 12 is still hypotenuse. Cross multiplying, we get X is at 8.02 and change. Keep it all the way out. We'll double it. That gives us 16.059. And now we can round to the nearest integer, which was 16. For 7. So we have kilo, hecta, our base unit, kilo, hecta, deca, our base unit, deci, centi, and then milli. So if we're going from meters to kilometers, meters is our base unit, we'd be here. Going to kilometers, we're jumping 1, 2, 3 units to the left. So start your decimal point where it is, go 1, 2, 3 units to the left, so we end up with 2.5 kilometers. We're going kilograms to milligrams. So here's kilograms. To get to milligrams, we're going 1, 2, 3, 4, 5, 6 units to the right. So start where your point is between the 2 and the 5, and we'll jump 1, 2, 3, 4, 5, 6 units to the right, fill in the blank spots with zeros, and we get 2,500,000 milligrams. We'll do one more illustration, and then you can just check your answers for the other ones. We're going to go down to E. Let's see, we're going to decameters, and we want to go to, sorry, we're at decimeters, and we're going to go to meters. So we're going to go 1 to the left. So we're starting here, 1 to the left, we get 9.0, which is the same as 9. And then the other ones are similar ideas. Just start where the number is that they gave you for the units and move either left or right to what the new units you want. Most commonly, we will see problems where we have to switch between centimeters and meters or vice versa. That's the main place that it comes up in our problems. All right, moving over to page 65, we're going to talk about density today. So density is a ratio. Typically, density is the mass of something divided by the volume of something. But it could, if you're talking about population density, it could be like a people amount divided by a square miles amount. So here's some examples. So if you want to determine how many rabbits there are in a certain area, you're finding the population density of rabbits. So you're finding the rabbits per square mile. So to find that, all you would do is take your number of rabbits and divide it by whatever the miles squared is that you're working with. And the next one, a bushels per acre. That per in math means to divide. So you'll just take your bushels amount and divide it by your acres amount. And that'll tell you your bushels per acre. And if you want to study volcanic eruptions and you want to know the eruptions per square mile, again, per means divide. So you'll just do your eruptions number divided by miles squared. So the units actually tell you the operation you're going to do. It's going to tell you to do what divided by what. So population density is when you have a number of things divided by a unit of area. So a common one that we will see is people per square mile. So that will mean take the people, divide it by the miles squared. So that's for a population density. If you just have plain old density, that's typically a mass divided by a volume. So for example, right below, if we had a volume of 15 centimeters squared and a mass of 45 grams, to find our density, which I'm going to label as D, we'll just take the mass amount, which was 45 grams, divided by the volume amount, which was 15 centimeters cubed. and therefore our density, if we divide those, is just going to be 3. And our units is going to be grams per centimeter cubed. And you represent that usually with a slash between, because per really means division. So grams slash centimeters cubed. And we would read that as 3 grams per centimeter cubed. Now, in this problem, the volume was given to us, this 15 centimeters cubed. In most of our word problems we're going to see, it'll be up to us to calculate the volume, and it'll typically be a shape like we've been working with in the previous days using our volume formulas. All right, moving over to 66. So we've got the volume of a gold statue is around 1,000 centimeters cubed, and they give us the density is 20 grams per centimeter cubed. We want to find the mass of the statue. So again, our density formula, density is equal to mass divided by volume. Well, we don't know the mass, so we're going to be solving for m, but we should be able to just fill in the other spots. The volume was 1,000. The density was 20. And we can just simply put the 20 over 1 and cross multiply. And we'll get that our mass is just 20,000. And if our density unit was grams per centimeter cubed, that means our mass unit should just be grams. Really what's happening here, I will just show you with units, the 20's units was grams over centimeters cubed, and we multiplied by something whose units was centimeters cubed. Well, notice there's a centimeter cubed in the denominator and the numerator. Those divide each other out, and all you're left with is grams. So that's why the mass unit becomes just grams. All right, next one, we've got Cassandra. She finds a chest with some metal coins in it. We know the volume of the chest, and we know the combined mass of the coins. So Cassandra is interested as to what metal the coins are made out of. She hopes she finds gold because it'll be worth more money. So we can do this with a density. As a reminder, density is equal to mass divided by volume. So we'll take our entire mass of the coins, the 2,625 kilograms, divided by the volume, which is 0.25 meters cubed. Our units for this will just be kilograms per meters cubed. And take a moment with your calculator, see if you can divide that, and then decide which metal we are working with. So we should have got 10,500 for that. So therefore, those coins must be silver. All right, next up, we're gonna work with a population in Anytown, New York. So they've got 32 people per square mile. What that's representing is a population density. Another town in West Virginia has a population density of 78 people per square mile. We know our square miles for each of them, so we want to know who has more people. So first off, in general, population density we find by doing the people divided by the square miles, the miles squared. We know the population density for each location, and we know the square miles for each location. So we can use that to find the people. So let's do Anytown. The population density was 32 people per square mile. We don't know the people. I'm going to call it P. The square miles was 106. So we can simply just put the 32 over 1 and cross multiply. We'll get P is equal to 3,392 people. We're going to pause the video for 2 minutes, and we're going to see if you can find the number of people in the other town. Our population density was 78. We don't know our population. We know the square miles is 80. So if we cross multiply, we should have gotten 6,240 people. So the question, though, asked for which town has the most people and how many more. So I guess Grahamville is how we would pronounce that. So it looks like Grahamville has more, but to find how many more, we can find the difference. So we'll take that 6240 minus 3392. And for that, we get 2848 people. So we'll just write a little summary. So Grahamville has 2,848 more people. All right, well, we'll keep the video rolling, but we'll give you a minute to read through question 5. All right, so our goal in this is to find what would the mass of 500 bricks be, and then to be able to compare that to the capacity of the trailer, which is 900 kilograms, basically to see if the trailer can hold the number of bricks that we need. When you have density or volume word problems, you need to be on the lookout for unit consistency. So our dimensions of the brick are all given in centimeters. Our density is kilograms per meters cubed. And then later we talk about kilograms for the capacity of the contractor. So notice kilograms is unit consistency. We got kilograms in the density, kilograms for the trailer. But our volume and distance units, there's not consistency. We have meters cubed in the density, but centimeters in the bricks. Because meters cubed is the density, we need our bricks to be in terms of meters. So if we go back to our homework, if you are currently at a centimeters and want to go to meters, we should be moving our decimal places 2 to the left. So let's redefine our bricks. If we move this one 2 to the left, we'll have 0.051 centimeters for that dimension. If we move this one 2 to the left, we'll have 0.102 centimeters for that dimension. And move this one 2 to the left, we'll have 0.203 centimeters for that third dimension. So our bricks, we'll just draw a rough picture. If you have to draw a three-dimensional prism type shape, just overlap one of the corners and then just connect all the corners. And this may not be to scale. I'm just going to randomly label the dimensions. So a brick is a prism, and we're going to find the volume of this brick. Nothing in the question tells us to find the volume directly. But the units tell us that we should do that process. Because we want meters cubed, we're going to need to find a volume. Oh, and I have something I have to fix here. We switched our units, so these should actually be meters now, not centimeters. So if you copy down me writing centimeters there, switch that. These should be meters because we switched them from being centimeters because we wanted it to match that meters cubed. So again, what I was getting at with the green arrow is nothing in the question is specifically saying find the volume. It's up to us to recognize that meters cubed is a unit of volume, and that's what tells us we must calculate the volume. So our brick is a prism. From our reference sheet, we have capital B times H, which means the area of the base times the height. So our area of our base is a length times a width, so we'll have 0.51 times 0.102, and then times the height, the 0.203. So take a moment, type that in your calculator, and write out your answer to a few decimal places and put dot, dot, dot. So we should have 0.00105 dot, dot, dot. And what I'll do is I'll get that on my calculator page so it matches yours. Okay, so our units on this currently is meters cubed. Eventually, we need to know kilograms. So let's carry down that 0.00105 dot, dot, dot meters cubed. And now the reason we're doing dot, dot, dot is this is not a final answer. You should never round anything until the end, and you only round if the question asks you to. We need to know about a kilograms though, so we need to convert our units. Whenever we convert units, we multiply by a fraction. Our current unit is meters cubed. So the next time meters cubed shows up, it needs to be in the opposite spot of the fraction. The thing we want to go to is kilograms. So the kilograms will go in the other spot of the fraction. 1920 kilograms per meter cubed implies that we're dealing with 1 meter cubed. So 1 will go in the meters cubed spot, 1920 will go in the kilograms spot. Because we have a meters cubed in the numerator and a meters cubed in the denominator, those units wipe out. And then we can multiply these two things together, and it will now give us a kilograms number. So let's go to our calculator. If we just hit times, it'll automatically take our answer that we already have all the way out. And we'll just multiply by that 1920. I'm going to show it as over 1 here, but the over 1 isn't doing anything for us in this particular case. So we get this 2027 number, so I'm going to copy that down and I'm going to put it with dot, dot, dot. 2.027 dot, dot, dot. Our units now is kilograms. So this is the kilograms for 1 brick. However, we have 500 bricks. So we're going to take that 2.027 dot, dot, dot. We're going to multiply it by 500, and that'll give us our kilograms for all 500 bricks. So we can just do times 500. So we get 1,013 and change. So we'll write that out with a couple decimal places. So 1013.705 dot, dot, dot kilograms. And this one, it doesn't ask us what the kilograms are. We just need to compare it to see if the trailer can hold it or not. So we would say, in this case, because our bricks, the mass is going to be greater than the capacity of the trailer, which is 900 kilograms, we would say that no, it will not. So can it hold the bricks? We will say no, since it would need to hold about 1014 kilograms. All right, we're going to look at one more problem in this video. So again, we'll keep the video rolling, but take a minute to read through that question. All right, so if we draw a little picture here, we've got these cylindrical tree trunks where the diameter is 50 centimeters, the height is 10 meters. Immediately, we should have alarms going off in our head. One of those was in centimeters, one was in meters. Well, if we read further in the question, the density is 380 kilograms per cubic meter. So because our density is in meters cubed, we want to work with meters. So let's convert our centimeters by moving it over to. So really, this is going to be 0.5 meters that we're going to work with. And again, that's for the diameter. There's nothing in the question that tells us we should be finding a volume directly. We need to recognize that unit is cubic meters, and that guides us to know we should do a volume. So from our reference sheet, we'll do our volume of the cylinder formula, which is capital B times H. We always need to replace capital B with the actual area formula for that basis shape, which is a circle in this case. So we're going to have our volume is pi times, if 0.5 is the diameter, our radius, half that is 0.25 squared, and then times the height, that was 10 meters. So we'll go ahead, put that in the calculator, and go ahead and put the pi right in and everything. So we should get 1.96 and change. So we'll put that here. So we got 1.96 dot dot dot. And our units, because we just found a volume and we used meters, was meters cubed. Well, eventually we need to get this into a dollars amount. So we're going to have some converting that we're going to do. So let's start with that 1.96 dot 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 meters cubed. The dot 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 signifies to the greater that you are keeping the number out in your calculator, and we want to keep that out. You should never be rounding intermediate answers. So to convert, we're going to multiply by a fraction. Meters cubed is currently in the numerator. So next place meters cubed shows up has to be opposite spot of the fraction, so denominator. We had 380 kilograms per cubic meter. That implies per 1 cubic meter. So 1 will go in the meters cubed, 380 will go for the kilograms. At this point, we've got a meters cubed in the numerator, meters cubed in the denominator. The meters cubed units would wipe out. If we were to multiply this, we would get a kilograms answer. But we want a dollars answer, so we got to keep converting. So let's multiply by another fraction. Kilograms is currently in the numerator. Next time kilograms shows up, it must show up in the denominator. The conversion we have is it's $4.75 per kilogram. This implies it's per 1 kilogram. So we'll put 1 kilogram on the bottom. We'll have $4.75 in the numerator. Because kilograms, its unit was in the numerator and the denominator, those units wipe out. If we were to multiply this now, we would get a dollars answer back. So let's go to our calculator. If we just do times, it'll take our automatic full answer all the way out. If that answer was up higher, we would just scroll up and highlight it and hit enter to bring it down. So we're going to do times, we'll do a fraction, control divide. We'll do that 380, which was in the numerator, over 1 in the denominator. You technically don't have to do the over 1 because dividing by 1 doesn't do anything. But I want to just illustrate it to show we're just trying to make it match exactly as it looks on our paper. Then we got the 4.75 in our next numerator, 1 in our next denominator. If we hit enter, it'll give us a cost amount. This is not our final answer, so we're not going to round this yet. So we get a dollars amount, we got 3544.109 ... Well, this is the cost of one tree. And we want to know how many trees for $50,000 to be raised. So we're going to take 50,000 and we're going to divide it by the answer we just got, the 3544.109 ... So let's go over to our calculator. We can do 50,000 divided by, and then just scroll up, highlight our answer, hit enter to bring it down, and it'll divide it by that entire number with all the decimals for you. You also can use your hotkeys like on the Google Doc. You could do Control C and then come down and do Control V, and that works as well. And if we hit enter, we got 14.107 as our exact answer. So that would be the exact amount of trees to cut down. Well, we need whole trees. So our answer is either going to be 14 trees or 15 trees. So we've got to think about what is that first number of trees that would work. If it's 14.10 exactly, if we cut down only 14 trees, we will be a little bit short of our goal of 50,000. So we must cut down 15 total trees to hit 50,000. We'll get a little bit extra money as well, but it'd be 15 whole trees in order to reach our goal. All right, so we will stop there for this video. Anytime left, you can start working on the homework. Remember to be really cautious of unit consistency in these word problems. Have a great rest of your day.